Okay, so I'm Adam McKenna. I'm with Pinterest, and my talk is entitled Enabling Invisible OS and Platform Upgrades for Canary Analysis, but that didn't all fit here, so I just shortened it a little bit. If you're not familiar with Pinterest, it is sort of a discovery engine. It enables people to discover things, do visual searches, share links, share photos, a lot of different things. I'm sure some of you are on there. Our mission is to bring everyone the inspiration to create a life they love. A little bit about our scale. Currently, we are about 30 million monthly active users. That's from our latest quarterly report. It's probably more than that now. We have about 80,000 hosts under management, and most of those hosts run multiple Docker images. We have a microservice architecture that deploys Docker images to all of our hosts, or most of our hosts at least the stateless services. A little bit about me. I'm on the core SRE team at Pinterest. We're responsible for overall uptime and some of the internal services we support, mostly to do with provisioning and things like that. I've been a Linux user since 1993. Been a sysadmin since 1998. I started in Windows, but I still count that. And I've been doing DevOps since, I originally said 2012, but I changed it to early 2000s because I did do some work on the Debian project, and I think that can be considered DevOps, even though it was before the word DevOps was invented. And if you look in, I'm not a Debian maintainer anymore, but if you look in the code, there is, you do find my name in a few places, still floating around. Nothing important, though. So a little bit about this talk. The target audience, basically, I don't know why it's doing that. You are a DevOps, an SRE, a sysadmin, a release engineer. You don't like having prod issues. I think that pretty much covers everyone in the first set as well. And you're looking for ways to improve reliability of your deploys. And the key takeaways I want you to take away from this talk are, you should understand what Canary Analysis is, what it isn't. You should understand what it's useful for. I'm going to give you some practical considerations for your implementation. And I'm going to show you an example system using the components that we use at Pinterest. So there are some prerequisites for deploying Canary Analysis in your organization. The first one is that you really need to already be deploying using continuous integration. Canary Analysis is sort of a step in that process. It's something you add to that process, but if you don't already use CI/CD, Canary Analysis probably will not be useful for you, since really the automation part of automated Canary Analysis is the big time saver and force multiplier. Another thing you need is to have your critical service metrics stored in a time series database. If you don't have this, that needs to be done first. Canary Analysis only works on data that it can fetch from a time series database. So if you don't have that, you would need to have that before you implement Canary Analysis. And the most important thing probably you need is organizational buy-in. With any big project, you need this, obviously, and your politics, internal politics of your company may vary, I'm sure, but it's such a large organizational change, and it also is enough of a change in the way of thinking that it really makes, it really matters to have organizational buy-in at the highest level possible, because some of this may not be things people want. Canary Analysis or CI/CD is sort of a baby step toward full automation with Canary Analysis. It can, like I said, it can represent a major change in the way your organization does things. You may get pushback from service owners. You may get pushback from other people. So again, the buy-in is very, very important. So before we get started on the meat of the presentation, I just want to define a few things because I know I use kind of a clickbaity title. which was enabling invisible infrastructure upgrades with automated Canary Analysis. So the two words I want to define are invisible and infrastructure for the purposes of this talk. And when I say invisible, I mean that it doesn't require a significant time investment on the part of a service owner, right? It doesn't mean that they're unaware of what's happening. It doesn't mean that they don't have to do anything. But we want them to have confidence in the process. We want them to not think about the difference between a code deploy and an OS upgrade. Those should be the same in the minds of a service owner, even though they're completely different in our minds, and one of them is considered much more high risk than the other one. But we want the service owner to think of those as essentially equivalent, as both not being a big deal. The idea is that once you have this in place, Canary Analysis is just another step in your deploy process that nobody really thinks about. It does things for you, it saves you time, and it replaces the toil that we have in our migrations and upgrades today. And then to define infrastructure, Merriam-Webster defines that as the underlying foundation or basic framework as of a system organization. But for the purposes of this talk, I'm basically saying that infrastructure, or defining an infrastructure as any dependency of your application that, if changed, could potentially alter its behavior. So physical hardware, maybe your cloud provider is offering a new instance type. You want to validate your app on that version. Storage technologies, does the app perform significantly worse on hard drives, spinning disks, than it does on SSDs? Could we maybe save some money doing that? Well, I don't know. How do we test that? Your networking stack even, 100 gig versus 100 meg NIC, probably going to be an improvement, but then there's things like your operating system, the kernel, user space, your language runtimes, so compilers, Java runtimes, Python interpreters. All these things have to be upgraded, and a lot of the times we don't really know what the implications of that will be. You could even test pretty much anything with Canary Analysis, even if it's not actually affecting your metrics. I mean, you could test whether Carl wears a green shirt or a red shirt affects your system. I mean, hopefully, if you get a bad canary score from that, I would worry about your system. But technically, that's something you could test. So Canary Analysis, as the last term to define, essentially it is comparing two different things: a control cluster and a canary cluster. This is the image I thought of when I first heard the term Canary Analysis. It does have so when you do Canary Analysis, an important thing to remember is that you are deploying code to production. You want your code to be serving production traffic. That's the only way you can really expose every single potential bug. You can do a really good job with load testing and scripts and things like that, but you'll never catch every single problem. That does have an inherent risk. Deploying code to production can result in bad experiences for your users. But it's a lower risk than rolling out that code to every production system if you're only rolling out to a certain percentage. And you probably already do this sort of thing manually. You look at charts and graphs when you do a deploy. You say yes or no, is this a good deploy or a bad deploy, right? So we want to do that, but in an automated fashion. So infrastructure has an expiration date. That's the main problem. You know, there's a lot of different things expiring right now: Windows, Python, Java, Ubuntu. We are actually going through an Ubuntu migration right now. And then there's things like container runtimes, Ubuntu, Docker. Docker's doing quarterly updates now. Python, there's big migrations 2 to 3. There's definitely plenty of things you might not be thinking about when you try to run your code on new Python versus old Python, especially performance aspects of that. Java, you might be wanting to go from Oracle to OpenJDK or just updating the Java major version. That itself can have an impact on your code and how it runs, and you might want to be able to test those sorts of things as normal deploys rather than something special. So obviously there are business needs for upgrades. Businesses need to meet industry compliance requirements, PCI compliance, SOX compliance, all those sorts of things. So they want everything to be on the latest version all the time. We need to retain support. We need to be able to get bug fixes for security bugs so that our systems don't get compromised. And we need access to new features. Latest hardware support, performance improvements that you might get from GPU drivers and things like that. And then developers, they don't want to have to maintain a bunch of different versions of things, right? They don't want to have to write that code. They don't have to do something different on different versions. So when the time to upgrade comes around, it's best if we can upgrade everything at the same time. That way we can minimize this. So we want to do our upgrades quickly. We want to do our migrations quickly. We don't want to do them over the course of a year, because then we have to write tons of things like this to compensate for that. That was what I meant by platform efficiency. But upgrading is hard. We don't like it. It's complex. At Pinterest, we have hundreds of microservices spread across tens of thousands of hosts. Service owners don't like downtime, obviously. They're usually measured by how much their system is up. And they like to push back when anyone says something that might cause downtime, right? We need to migrate your system to Ubuntu 18. Well, I don't know. That might cause downtime. Can we talk about it next week? They don't like to do migration work. Tech debt is not a preferred task. Nobody likes doing it. Nobody likes clean up stuff. Everyone wants to be working on the newest code for the newest features and not cleaning up things that other people wrote 3 years ago or 10 years ago, whatever the case may be. So Canary Analysis can help us. It helps us automate and normalize these mundane tasks. So for example, automation helps us eliminate the toil. So we no longer need to look at charts, compare metrics when we do a deploy, hopefully. And then we can normalize things. The same process can be applied across many different systems. So if you have 100 Java services, once you've done one, you pretty much have a lot of the signals you need from that to do the rest of them. So we can save that work on the part of those other 99 services, or at least a part of that work. Canary Analysis isn't. It is not a replacement for traditional testing patterns. You still need unit and integration tests. You still need service health checks. It's not mysterious or magical. A lot of people, I've even encountered very technical people who were like, I don't know what this is doing. Well, it's running a statistical analysis across 50 data points that we pulled from your metrics. I mean, it's not magic. It's not mojo. It's just very, very boring stuff, really. It's not off the shelf yet. You cannot buy a product that you can deploy and say, we have Canary Analysis now. The closest thing that's available right now for doing Canary Analysis is a plugin for Spinnaker called Kayenta. That's the most off the shelf it gets right now. You're still going to need to do some, to write some custom code if you want to avail of this sort of thing. And the other thing it's not is instantaneous. You do need to allocate time during your deploy process to run these clusters and make sure that they're, that your Canary is good before you roll that out to production. And I do get a lot of pushback on why is this adding 30 minutes to my deploy? Why is this adding 2 hours to my deploy? And the reason really is that you need to add that time to make sure you have a good Canary Analysis. It's not really optional. And there are plenty of supporting documents on the web that echo this sentiment. So you can show those to people if you need to. So here's the typical migration. This is typically how it goes, right? A new image is released. Hey, we have a new Ubuntu 18.04 image. Everybody start using it, right? People start to upgrade. They say, OK. They go in their little system and they click, in the drop-down, they click the new one. They click deploy or rotate cluster, whatever they're supposed to do. People watch the charts. They cross their fingers. Did everything go good? OK. Go back to work. Anything go bad? Well, now we have an incident. We have an outage, maybe. We have to roll back, right? So here's an example of that. We have 2 charts here, CPU, memory, and I/O. And one is the control group on the left there, and the right one's the canary. How many people would say, yes, this looks like a good deploy, let's push this out? Raise your hand if you think this is good. Okay, good. Nobody raised their hand. Obvious failure case, right? CPU pegs at 100%, I/O drops to almost nothing. We know this is definitely not something we want to deploy. So we'd say, no, roll it back. But sometimes humans can disagree on things, right? What if the charts look like this? Would you say yes or no? Controls over here, canaries on the right. Does canary look good? I mean, the numbers look a little better, but they are different. People might have differing opinions on that, right? So what might the service owners think if they have different types of personalities? So this is Gene. Gene services his baby. He's very risk averse. He's got 8 nines of uptime, but he's still running on Ubuntu 10.04, which is like 10 years old. Went out of life, like end of life years ago. Gene's like, no way. Let's look at that. Look at that I/O line. Let's meet on Monday and figure out what's going on, right? That's something Gene would say probably. Now you've lost a few days at least of time, and now you have to have a meeting with Gene, and that's never fun. This is Angus. His last job was at a Bitcoin startup. He likes to move fast and break stuff. He yells, "Tonight we test in prod," at least once a day. He says, "Looks good to me, ship it." And this is Carol. I don't know if you guys realize, but these are all Snapchat filters of me. That's the gender bender one. Carol has 100% test coverage on all her code. She's researching statistical models to improve fault detection. Well, Carol says, I'm going to need a couple hours to run more tests, right, against these new hosts. Stand by. So that's great, right? Carol's like model employee. But Carol's work is only being leveraged by her group, right? It's not being leveraged by all the other groups that are looking at these same charts and making these same decisions all the time. Now Carol has to do extra work every time there's a deploy where these charts are not completely cool by our standards, right? It's fine if it happens once, but if it's every single deploy or every single migration, Carol's eventually going to get tired and burn out. And then once you have deploys going, tens of times a day, Carol can't possibly look at every single deploy and give a yes or no, right? And then there's also the employee who left the company. Do you ever do this? Get on Slack and be like, hey, I need to talk to Bob about this, and I'll just punch him up on Slack, and then, oh, Bob left 2 weeks ago. Well, crap. Now we have to figure out what to do. Everybody has to put in time. Canary Analysis helps us by allowing us to capture all this configuration as code in the system, rather than relying on what's in people's heads. So moving on to practical considerations, there are a lot. I'm not going to lie. So as I already mentioned, you do need an existing CI/CD pipeline to integrate into, and some workflow orchestration. You need a time series metrics database, so OpenTSDB. There's a bunch of them that Kanta supports, and you can write your own plugins if it doesn't support your preferred one. We actually had to write a plugin for OpenTSDB since that's what we use. You need an execution environment for custom code. So like I said, all of this Canary Analysis products, essentially Kanta and Spinnaker are the most mature, but you will wind up writing your own code, and you need a place to run that code, either on, for example, we use Jenkins for this, and Jenkins might be a bad word for some people, but it serves its purpose in this regard. And you need a Canary Judge software, which Kanta is the plugin for Spinnaker that we use, and it does pretty well. So this is sort of an example system. This is basically what we use. I don't know how well this is going to come across to all of you, but it's kind of complicated. But essentially, we have Spinnaker storing its config on S3. The Kanta plugin is part of that. When a new deploy is triggered, it's triggered through Spinnaker. Spinnaker talks to its config. It triggers whatever build steps happen or whatever deploy steps have to happen before the Canary Analysis, such as updating the code on the Canary clusters. When that's done, we trigger the analysis via a webhook, and that rolls if that's successful, then the code rolls out. And these slides will be available online, by the way. So this is essentially, and our custom code does a bunch of different things. It handles the provision and deprovision via the EC2 API, and it handles triggering the deploys through our deploy system called Teletran. And that's actually open source too. It's usable by anyone. So essentially what we wound up doing is writing a Python CLI. In terms of best practices, sorry, I forgot to animate this one. Canary control should be similarly sized. It can help if you have a per host metric versus a per cluster metric, then maybe that doesn't need to be the case. But in general, we like to have things the same size so that we can be sure that they're handling about the same amount of traffic. They should be serving a meaningful amount of production traffic. Minimum of 50 data points. And meaningful is whatever that means to you. If there's a high amount of variation in your data that's causing canaries to fail, it's very possible that you're just not giving the canary enough traffic for it to make a good decision. You do need a minimum of 50 data points. That's in pretty much every Canary Analysis best practices guide. And you need to have good metrics that really reflect your application's health. If your application is not a huge CPU consumer, then maybe looking at CPU is not going to be very, very useful for you. So you need to know what metrics signify that your application is healthy. And there is a lot of guidance available for this on the web. One of the things is the four golden signals, latency, traffic, errors, and saturation. And I did link that down at the bottom. But it's in the Google SRE handbook. The overall effort for us was about 1 year effort for 2 to 3 full-time engineers, and nobody actually worked on this full-time, but that was probably about what it was for the effort. We'd have to write our own custom Python CLI, like I mentioned. It's about 700 lines of code, not including tests. Kayenta did not have native support for OpenTSDB, so we wrote our own plugin. We eventually hope to contribute that back to the open source community. So the lessons learned for us, at least the important lessons learned, and especially for me, was that UX is very important for this process. The user experience of your service owners will dictate how quickly and how quickly this is adopted and how well it's received by the company. Don't pilot Canary Analysis with Gene's app, because Gene will potentially slow the process down. Or do pilot ASA with Gene's app, because Gene, if you can make him happy, you can make anyone happy, right? Save good and bad builds to test with. This is a problem we had. Well, actually, I guess it's a problem we had, and also a good thing that we save tons of old builds. But we've definitely improved that over the time this has been in process. Let's see. And here are some additional resources. There are plenty of resources on the web for Canary Analysis. There are a lot of blog posts, a lot of how we did things from very large companies such as Netflix, Google, Waze. And they're really good reading. This is a very, very complicated and detailed topic, and I've only barely touched on it today. So I hope this was useful to you. Another thing is we're hiring at Pinterest on our SRE team especially, so come work with us. I know this says SRE Con, but it still works. I did give this presentation at SRE Con a few months ago, or a similar presentation. And that's pretty much it for me. Is there any questions?
Can you talk a bit about your experience and how, after you rolled this out, how it was received, and if you have any kind of metrics on how much time you saved people not watching and doing manual Canary analysis?
I don't have metrics on that. Since we already had a I wouldn't say that it saved much time because we already had a deploy pipeline that was deploying things and not canarying them. So, you know, all the issues we detected would make it to prod before we detected them. So this has definitely been useful in catching errors before they go to prod. We did keep track for a while, and before we enabled the Canary Judge in the deploy pipeline to do automatic decisions, we did watch it for a while, and we did see that it detected quite a very high percentage, definitely more than 50% of the issues before they were deployed to prod, and that definitely helped us with convincing people to adopt it.
You mentioned the UX is important, obviously. How are you showing the UX? Or like,
So,
is there a UI for the user side?
Well, UX I just meant by UX, I just meant overall experience.
Right.
It's really just how easy you make things for the service owners. The easier you make things, the more likely they will be to adopt them. So a few things that we went through while going through this process is, you know, figuring out that we needed to have the SREs determine a lot of these things, at least determine sane defaults for many of these metrics, because when we went to service owners and we're like, well, what are your metrics? And they had no idea a lot of the time. Because their SRE set it up or one of us set it up for them.
Do you have any kind of interface for them to see the results so they can see what's happening?
Oh, yes. Kayenta actually provides a pretty nice interface for looking at the charts and everything. And it tells you like the deviations for each metric. It's really cool.
What sort of statistical analysis do you do? Like, how do you actually decide automatically whether something's good or not?
So, I actually didn't touch on this, I guess. The Canary Analysis that Kayenta uses, or the Netflix Canary Judge, is actually what it's called. It applies a statistical analysis called the Mann-Whitney-Hughes test. And if anybody here is a math major, maybe you've heard of that, but I had never heard of it before. Essentially, what it compares is it takes two sets of data, and they don't have to be, the important thing about it is that they don't have to be the same distribution. And it compares them to see what the probability is of a point in one set being statistically the same as a point in another set. And it provides a score called the U factor based on that. There are a few other algorithms that are used, or competing algorithms in Canary Analysis, and you could certainly write, you know, since I mentioned this code, you do definitely have to write a decent amount of glue code for this. One of the things our service owners wanted that is not done by the Canary Analysis is being able to provide a metric or a threshold for a specific metric or a set of metrics that they don't want exceeded. The Canary code doesn't really support that. I mean, it sort of does. In Kayenta, you can do it through like the API, apparently. I wrote a little bit about that on their Slack, but it's not something that's officially supported, and they said they're probably going to remove support for that. But it's really something that's fairly simple to do in your own code. I mean, really all you need to do is import SciPy or, you know, another math library and pull those same metrics out of your metric system and apply whatever analysis you like to them. And we also require that the applications have health checks that accurately, or hopefully accurately, denote that their application is healthy. And we check that in a separate step. We don't check it during the Canary Analysis. We assume that the basic application functionality is healthy by the time we get to that Canary step. And if it's not, we roll back before that.
Great presentation. So you have a stateless app. You can compare the Canary metrics. So how is this? How do you solve the problem for distributed systems, or like any clustered database or anything?
We've only implemented this for stateless systems so far.
Okay. Yeah. Thanks.
Hi, thank you for the talk.
Thanks.
We have a very high level of standard for what we want to provide to our customers. So pushing something into prod that hasn't had this level of testing is something that we don't really want to do. Do you have any solutions which may like replicate what you're seeing against production sort of instances and say, can we test this in another sort of similar sized VM or whatever, and then see how that performs for the Canary test, or does this rely heavily on being in prod?
I understand. I totally understand that concern. I did think a little bit about this. We've never really discussed it because we are okay with it. What I would probably do if I wanted to implement something like that is implement some sort of mirroring of production traffic to another set of servers that's isolated and not actually recording those responses back to the customer. I think you could probably get a good simulation doing it that way, but I think it might be like really, really complex to figure out how to do that.
Great, thank you.
How do you know how long to wait between when the Canary is deployed and when it gets promoted to production?
What do you mean?
So how much data do you collect before you say, okay, it's good?
You need about 50 data points, so you could potentially get that in a minute, or you could potentially get that in 2 hours, depending on how long it takes for you to get a good idea of how healthy the application is. Most of the best practices docs say between 30 minutes and 2 hours is probably reasonable.
But like, what if you have a very complex traffic pattern? So you deploy in the morning, but the thing that's going to break you might not come till the evening. Would that necessitate waiting even longer?
Well, I mean, between the morning and the evening, we've probably do 20 deploys to prod.
Right. Yeah.
Yeah. So the way that it's sort of works is we have the deploys sort of like each one is going, like they're going in parallel. So, the total time from commit to production is really what you're going to be concerned about, and there are many ways to measure that and improve on that. But the Canary stage of the deploy will take between 30 minutes to 2 hours to get the needed number of data points.
Okay.
Hello. Great talk, by the way.
Thank you.
I just had a question. Have you had any instances where you have any false negatives or false positives, like your Canary system, something didn't?
Yes.
Yeah.
Yes, a lot.
How do you handle that?
Especially when you're first bringing systems onboarding systems, you get tons of false positives because you haven't yet figured out which of the metrics are very important and tuned their weights appropriately in the system. And you can weigh out, you can lower the weights of things that are less important and increase the weights of things that are more important, so that, and then what Kanta does, you can give it a threshold and say that if 75% of these pass, then we consider it successful Canary. If 50%, we consider it marginal and we send it for a manual decision. And if it's below 50, we just roll back automatically.
Okay. Thank you.
Any further questions? Okay, thank you, Adam,
All right,
again.
thank
I'd
you,
like
everyone.
another round of applause for Adam.